Welcome to finding points of inflection. So just a reminder that points of inflection can only occur where the second derivative f double prime is equal to 0 or is undefined. And we just need to check that concavity changes. So the method will be more or less what we've done before. So we're going to find the second derivative. Then we need to find where the second derivative is equal to 0 or is undefined. Then we need to break into subintervals. Then we pick a test point. In each subinterval. Find the sign of the second derivative at each test point. Determine where f is concave up and concave down. And then identify where the concavity changes. So we're doing precisely what we did for just determining where it's concave up and concave down. We're just adding that final step of identifying, is this point a point of inflection or not? So let's go ahead and find the points of inflection for f of x equals 3x to the 5th minus 5x to the 4th minus 10x cubed plus 30x squared plus 5x minus 2. So the first thing we need to do is find that second derivative. So f of x was 3x to the 5th minus 5x to the 4th minus 10x cubed plus 30x squared plus 5x minus 2. So our first derivative becomes 15x to the 4th minus 20x cubed minus 30x squared plus 60x plus 5. Our second derivative is therefore 60x cubed minus 60x squared minus 60x plus 60. Our next task is to find where this is 0 or undefined. So once again, we're working with a polynomial, so it is never undefined. where it is equal to 0, we're looking for 60x cubed minus 60x squared minus 60x plus 60 is equal to 0. We can go ahead and factor a 60 out front. So we're left with x cubed minus x squared minus x plus 1, all equal to 0. We're now going to do factor by grouping. So let's go ahead and group x cubed minus x squared and minus x plus 1. That first group, we can factor out an x squared. And we're left with x minus 1. The second group, we can factor out a negative 1, and we're left with x minus 1. Then we can take our x minus 1s and pull those out front. And we have 60 times x minus 1. Inside, we are left with x squared minus 1. All equal to 0. X squared minus 1 is x minus 1, x plus 1. All of this equal to 0. So we have 60 times x plus 1 times x minus 1 squared equals 0. And so this can happen either x plus 1 equals 0. And so we get x equals negative 1. Or x minus 1 equals 0, and therefore x equals positive 1. Now we are going to go ahead and draw our number line. And if we draw our number line, our points of interest, oops, sorry, that should be x. We're at x is equal to negative 1, positive 1. Now at these two places, the second derivative was equal to 0. We have test points to pick. We might as well pick negative 2, 0, and 2. Again, the second derivative was equal to 60 times x plus 1 times x minus 1 squared. If we look throughout our signs, 60 is always positive. X minus 1 squared, well, once we square, we'll switch to positive or 0, but we already know that point. And then x plus 1 will switch at negative 1. So if we plug in negative 2, the second derivative evaluated at negative 2, that first factor is positive. Then negative 2 plus 1 will be negative, and that last factor is positive always, so we get a negative. At 0, we have a second derivative evaluated at 0. That first factor is positive. Then 0 plus 1 is now positive. The last factor is always positive, and we get positive. And then at our last one, once again, that second derivative evaluated at 2, the first factor is always positive. 2 plus 1 is a positive 3, and that last factor is always positive. We once again get positive. Now, if we do our concavity, we look at what f would look like. Second derivative is negative, we're unhappy, so we are frowning. First derivative, or sorry, the second derivative is positive, we're happy, so we're smiling. And the second derivative is positive, we're happy, so we are once again smiling. So we only change what's happening if we go from between concavity. So we change concavity at 1. So we'll have a point of inflection. On the other hand, sorry, at -1, we have a point of inflection. At 1, we don't change concavity, so there's no point of inflection. So this is not a point of inflection. So in this case, we just have a single point of inflection. So x equals -1 is the only place where there is a point of inflection. And the point of inflection itself would be the point -1 comma f of -1. All right. So this is points of inflection. Again, it's the same exact process for finding where it's concave up and concave down. We are then just looking for where it actually switches between concave up and concave down. So this first one, we went from concave down to concave up, whereas the second one, we stayed concave up, concave up. So that one was not a point of inflection.